The shell hit at 200 meters per second. The Weld held. The crew lived. This is the story of a battlefield modification that military engineers said violated every principle of proper tank construction. But it's really about the moment when field improvisation collided with engineering orthodoxy, when survival instinct trumped technical perfection, when a welder's gut feeling about where metal needed to be proved smarter than the doctrine written in manuals back in Britain, and what it reveals about the gap between what looks right on paper and what actually works when your life depends on it. May 1943, the North African desert near Medjez el Bab, Tunisia. Churchill tanks of the British Army's tank regiments were getting shredded by German 75mm anti-tank guns, and the crews were dying because shells were punching through welds that had passed every quality inspection before the tanks shipped from the factory. The welds were perfect according to specifications. They were uniform, clean, properly penetrated, exactly what the engineering manuals demanded. And they were failing in combat because nobody in those factories had ever watched a 75mm armor-piercing round hit a joint at an oblique angle and tear it open like a zipper. Staff Sergeant Thomas Harker was a welder in the Royal Electrical and Mechanical Engineers attached to the Churchill squadrons. 28 years old, trained at a Sheffield steel mill before the war, assigned to field repairs because someone noticed he could weld faster and cleaner than the regular army technicians. He had watched 3 Churchills come back from patrol with catastrophic penetrations along the hull welds in 1 week. 3 tanks, 11 crewmen dead. The shells hadn't punched through the armor plate itself, but had exploited the joint where the side armor met the frontal glasses, that perfect factory weld splitting apart under impact and letting the round tear through into the crew compartment. The official response from the engineers back at headquarters was that the welds were fine, that the armor scheme was adequate, that crews needed to position their tanks better to avoid exposing those joints to direct fire. Harker read the memo and felt something he couldn't quite articulate at first, a kind of fury mixed with disbelief. These men in their offices were telling tank crews to simply not get shot in the wrong place, as if battlefield geometry could be controlled through better tactics, as if German gunners would politely wait for British tanks to present only their strongest angles. That night, unable to sleep in the maintenance tent, while another damaged Churchill sat 20 meters away, waiting for morning repairs, Harker walked out to look at the tank. He ran his hand along the weld seam where the hull side met the front plate. Perfect bead. Smooth transition. Exactly what he had been taught produced the strongest joint. He thought about the Sherman tanks the Americans were using, cruder welds in some ways, but with these ugly reinforcing gussets welded over critical joints, extra metal that looked sloppy and inelegant, but created a kind of overlapping strength that gave shells something extra to chew through before reaching the crew. The belief he had been taught his entire career was that proper welding technique executed to specification produced optimal strength. That extra metal was waste. That reinforcement meant you had done the primary weld wrong. This wasn't just training, it was professional identity. A good welder made joints that needed no reinforcement. A good welder trusted the science of metallurgy and heat-affected zones and penetration depth. Adding extra metal over a joint was an admission of inadequacy. But the shells did not care about professional pride. Harker made a decision that could have gotten him court-martialed. Without requesting permission, without submitting the modification through proper channels, without waiting for engineering approval that might take weeks or never come at all, he began reinforcing the hull welds on every Churchill that came through his maintenance section. He cut strips of armor plate from damaged tanks awaiting salvage and welded them over the critical joints at 45-degree angles, creating overlapping layers of metal that would force any penetrating round to punch through multiple thicknesses before reaching the interior. The reinforcements looked crude, adding 50 kilograms of weight in awkward places, disrupting the clean lines of the hull. They looked exactly like what they were, battlefield improvisation by someone who trusted function over form. The other welders watched him with a mixture of curiosity and concern. One of them, Corporal Davies, asked him directly if he had authorization for these modifications. Harker's response was simple. "I have authorization from the 3 crews that burned to death last week." Davies did not ask again. 14 days after Harker started his unauthorized reinforcements, a Churchill from a squadron took a direct hit from a German PaK-40 anti-tank gun at approximately 800 meters. The engagement happened during a probe toward German positions near Longstop Hill. The German gunner was experienced, positioned in a carefully prepared fighting hole with excellent fields of fire. He aimed for the hull joint, that vulnerable seam that had proven so deadly to British armor. The 75mm armor-piercing round, traveling at over 700 meters per second, struck exactly where he intended. The shell hit Harker's reinforcement plate first. The additional layer of metal, angled to deflect rather than meet the round head-on, caused the projectile's penetrator to yaw slightly, losing energy and changing angle before it reached the primary weld beneath. When the round reached the main hull joint, it was already deformed and traveling at reduced velocity. The weld, which might have split under a direct perpendicular impact, held. The shell-gouged metal created a crater, sent fragments ricocheting inside the sponson, but did not achieve catastrophic penetration. The crew, Trooper James Whitmore on the gun, Lance Corporal Peter Mills driving, Sergeant David Fletcher commanding, Lieutenant Charles Anderson coordinating, and Trooper Robert Hayes loading, felt the impact like being inside a bell when it is struck. Their ears rang. Dust and paint chips filled the interior, but they were alive. The tank was mobile, and Fletcher was already screaming at Mills to reverse into cover, while Whitmore traversed the turret to return fire. When the Churchill made it back to the maintenance area, Harker examined the impact site. The reinforcement plate was deeply cratered, the weld beneath scarred but intact. He ran his fingers over the damage and felt something he had not expected. Vindication mixed with anger. Vindication that his instinct had been correct. Anger that it had required men dying before he trusted that instinct over his training. The crew found him there an hour later. Fletcher, the tank commander, was a man who had spent 8 months in North Africa watching friends burn, who had developed the 1,000-meter stare of someone who had accepted that survival was statistical rather than controllable. He looked at the damage, looked at Harker, and asked a simple question. "Did you do this to all the tanks?" Harker nodded. Fletcher's response was not gratitude, not initially. It was fury of a different kind. "Why did it take you this long? Why did headquarters not figure this out? Why did we have to lose men before someone decided that maybe, possibly, the engineers back in Britain did not know everything about how tanks actually die?" Harker had no answer that would satisfy that anger, because the answer was about institutional inertia and the gap between theory and practice, and the reality that military organizations are designed to follow procedure even when procedure is killing people. He said the only thing that felt true. "I should have done it sooner. I was afraid of being wrong." Fletcher's expression shifted then, some of the fury draining into exhausted recognition. "We are all afraid of being wrong. The men who are dead were afraid of being wrong when they questioned why we kept attacking the same positions in the same way. Fear of being wrong is killing us, as surely as German guns." Word of the successful armor stop spread through the regiment within hours. Tank commanders began specifically requesting that their Churchills be sent to Harker's section for the reinforcement modifications. The unofficial name for the modification became Harker's Patches, sometimes said with respect, sometimes with dark humor about needing patches, because the factory could not build a proper tank. Within 3 weeks, every operational Churchill in the regiment had been modified. Within 6 weeks, crews from other units were driving their tanks to Harker's position, sometimes without official authorization, to get the reinforcements applied. The official response from higher headquarters was instructive in what it revealed about how military bureaucracies handle innovation from below. The initial reaction was disapproval. Harker was informed through his chain of command that unauthorized modifications to fighting vehicles were prohibited, that he had violated technical orders, that the additional weight was affecting the tank's automotive performance and center of gravity in ways that had not been properly analyzed. An engineering officer was dispatched from Cairo to inspect the modifications and prepare a report. Captain Robert Thornton arrived, expecting to document a case of well-intentioned but technically unsound field expedients that would need to be reversed before they caused mechanical failures or compromised the tank's combat effectiveness. He was a graduate of Cambridge, trained in mechanical engineering, 24 years old with 2 years of military service, none of it involving direct combat. He represented exactly the kind of by-the-book technical authority that Harker had been raised to respect and obey. Thornton spent 2 days examining the reinforcements, taking measurements, reviewing the welding techniques, calculating weight distributions and stress factors, his clipboard filled with notations. His expression remained carefully neutral. On the 3rd day, he asked to speak with tank commanders whose vehicles had received direct hits after modification. He interviewed Fletcher and 4 others, asking detailed questions about impact angles, shell types, damage patterns, crew injuries. On the evening of the 3rd day, Thornton found Harker in the maintenance tent. The conversation that followed was not what either man expected. Thornton began by stating that the reinforcements violated specifications for proper welding practice, added unanalyzed weight in suboptimal locations, had been applied without proper metallurgical testing of the salvaged armor plate, and represented a systematic deviation from approved tank maintenance procedures. He paused, and Harker prepared for the order to remove all the modifications and face disciplinary action. Instead, Thornton said, "And they are brilliant. Crude, inelegant, metallurgically questionable, and absolutely brilliant. You have created a spaced armor effect using salvaged materials in field conditions. The oblique angle of the reinforcement is causing shell deflection and energy dissipation in exactly the way that our best armor designers are trying to achieve with far more complex schemes. You have saved lives with scrap metal and common sense." The cognitive dissonance in that moment was profound for both men. Thornton had arrived believing that proper engineering required controlled conditions, precise materials, calculated designs. He was confronting evidence that battlefield effectiveness sometimes emerged from violating every principle he had been taught. Harker had spent weeks believing he was operating outside proper procedure, waiting for punishment. He was being told by a Cambridge engineer that his instinct was sound. But Thornton's next statement revealed the institutional complexity. "I am required to write a report recommending removal of these modifications because they do not meet specifications. I will also include a recommendation that these specifications be revised immediately and that this reinforcement scheme be studied for potential wider implementation. Both things will be true in my report. You will probably be ordered to stop. The order will probably be wrong. This is how truth moves through military bureaucracy. Slowly, filtered through layers of people whose careers depend on following rules, resisted by those who wrote the original rules and cannot acknowledge they were incomplete." Thornton's report landed on desks in Cairo, was forwarded to London, was reviewed by committees of engineers who had never watched a tank burn. The official response took 6 weeks. During those 6 weeks, Harker continued reinforcing tanks, now with his commander's quiet approval, everyone understanding that it was easier to apologize later than to watch men die waiting for permission. The official response, when it came, was characteristic of institutional compromise. The modifications were not approved, but they were not forbidden. Tank commanders were given discretion to request field modifications at their own judgment. Formal research would be conducted into applique armor reinforcement. In the meantime, units could continue with present arrangements pending further study. In other words, we will not say you were right, but we will not stop you from continuing. And if your tanks survive better than others, we will eventually study why and then take credit for the discovery. But underneath that bureaucratic hedging was a more profound shift. Harker's reinforcements had forced a crack in the certainty that proper engineering could only come from proper channels. Other welders and mechanics began experimenting with their own modifications. Some worked, some failed. But the culture shifted from assuming that the factory knew best to recognizing that the factory had never been shot at. By August 1943, British tank development facilities were incorporating Harker's principles into formal armor schemes. By late 1944, applique armor reinforcement was standard on many British armored vehicles. The official documentation credited research and development facilities. Harker's name appeared nowhere in the technical reports. This did not surprise him. He understood that institutions require heroes who fit proper narratives, And a staff sergeant who violated procedure, no matter how effectively, would never be that hero. What stayed with him, what he would struggle to articulate years later when historians occasionally found him and asked about the modifications, was the psychological weight of that moment when he decided to trust his instinct over his training. He had been raised in a culture that worshipped expertise, that insisted proper procedure existed for good reasons, that treated deviation as dangerous. Everything in his professional identity told him that the engineers who designed those tanks knew better than a field welder with grease under his fingernails. But he had also watched men burn, and at some point the gap between what he had been taught and what he was witnessing became impossible to ignore. The cognitive dissonance was painful. It felt like betraying his profession to admit that maybe the experts were wrong. It felt like arrogance to believe that his field observations might matter more than their calculations. The easiest psychological path would have been to trust the system, follow procedure, assume that the deaths were tragic but inevitable results of combat rather than preventable failures of design. He chose the harder path, not because he was brave, he would insist later, but because the alternative required a kind of willful blindness he could not maintain. Once you have seen that something is wrong, once you have recognized that the emperor has no clothes, that the system is failing, that people are dying from fixable problems, you have a choice. You can unsee it, retreat into comfortable obedience, trust that someone else will fix it. Or you can act, accept the professional risk, do what seems obvious, even when it violates protocol. The other welders in his section eventually adopted his techniques. Some did so enthusiastically, liberated by permission to trust their instincts. Others did so reluctantly, uncomfortable with deviation from standard practice, but unable to argue with results. One welder, Sergeant Malcolm Price, asked him directly, "How did you know it would work?" Harker's answer was honest. "I did not know. I believed it would work, but belief is not knowledge. I was willing to be wrong in a way that might save lives rather than right in a way that definitely would not." That distinction between being correctly compliant and being effectively helpful is at the heart of this story. Military organizations, like most large institutions, are structured around the assumption that compliance with proper procedure will produce optimal outcomes. This is necessary for coordination, for logistics, for preventing chaos, but it creates a trap. When the procedures are based on incomplete information or untested assumptions, compliance perpetuates failure. The Churchills were designed by engineers who understood metallurgy and stress analysis and armor penetration physics. They were not designed by engineers who had watched those tanks get hit by German 75mm guns at oblique angles that created stress patterns the original calculations had not accounted for. The factory welds were perfect for the threat model the designers had in mind. They were inadequate for the actual threat the tanks faced. This gap between theoretical understanding and practical reality is not unique to tank design. It exists anywhere that people make decisions removed from the consequences of those decisions. The engineers in Britain were brilliant. Their calculations were sound. Their welding specifications were based on solid science. They were also working from assumptions that did not fully match battlefield conditions, and the institutional structure made it difficult for information about those mismatches to flow back and be incorporated. Harker was positioned at the interface between theory and reality. He could see both the engineering logic and the battlefield outcomes. He could hold both the knowledge that the weld should be adequate and the evidence that they were failing. That position, seeing the gap between should and is, creates a kind of psychological tension that demands resolution. Some people resolve that tension by dismissing the evidence. The welds are fine, the crews must be using the tanks wrong, better tactics will solve the problem. This is comfortable because it preserves existing beliefs and requires no admission of error. Others resolve it by dismissing the theory. The engineers are idiots who do not understand real combat. The specifications are worthless. Everything designed in an office is suspect. This is also comfortable because it justifies ignoring expertise and trusting only direct experience. Harker did neither. He held the tension, acknowledged that both the theory and the evidence were real, and looked for a synthesis. The welds were good but insufficient for this specific threat. The engineering was sound, but incomplete. The solution was not to abandon proper welding, but to augment it with additional protection in vulnerable locations. This is harder psychologically than either dismissing the evidence or dismissing the theory. It requires accepting that smart people can be wrong, that you can be right even when you are breaking rules, that truth is sometimes found by combining official knowledge with unofficial observation. It requires comfort with ambiguity and a willingness to be wrong in ways that violate your professional identity. The belief system Harker was raised in told him that proper craftsmanship, executed to specification, was inherently superior to improvisation. That rules existed for good reasons, that deviating from standard practice was how mistakes happened. This was not propaganda. It was the accumulated wisdom of industrial society, the foundation of quality control and engineering reliability. It was also, in this specific case, incomplete. What makes this story philosophically interesting is not just that Harker was right to deviate from procedure. It is that he was right to deviate from procedure while also understanding why the procedure existed. He was not rejecting expertise in favor of gut feeling. He was using expertise as a foundation and adding battlefield observation to create something neither the experts nor the field experience alone would have produced. The reinforcements worked because Harker understood welding metallurgy, understood armor penetration mechanics, and also understood what shells did to tanks when they hit at specific angles that the original designers had not fully accounted for. Remove any one of those types of knowledge and the modification fails. Use only textbook knowledge and you get perfect welds that split. Use only battlefield observation and you get random armor stuck to tanks with no understanding of why it sometimes helps. The synthesis required humility about the limits of both theoretical and practical knowledge. It required being willing to say, "The experts know more than me about many things, and I know something critical they do not." And the path forward requires combining both types of knowledge, even though that violates the normal hierarchy of who gets to make design decisions. Military organizations struggle with this kind of synthesis because they are necessarily hierarchical. Decisions flow from top to bottom. Expertise is concentrated in specialized roles. This is essential for coordination, but creates barriers to information flowing from bottom to top, especially when that information suggests that the people at the top made mistakes. Harker's modifications succeeded tactically, but threatened the institutional narrative that proper design comes from proper channels. Acknowledging that a staff sergeant with no formal engineering education had improved combat effectiveness through unauthorized modifications meant acknowledging that the system had failed, that men had died preventably, that the hierarchy of expertise was less reliable than believed. So the institution did what institutions do. It absorbed the innovation while obscuring its origins. The technical principle was validated, incorporated into official designs, credited to proper research. The individual who discovered it through violation of procedure was quietly marginalized from the official history. This is not conspiracy or malice. It is the immune system of bureaucracy, protecting itself from the cognitive dissonance of acknowledging bottom-up innovation. But the tank crews remembered. Fletcher made sure that every new commander rotating into the squadron knew the story. The modifications became known as Harker's patches throughout the regiment, and that name persisted, even after official documentation called them applique armor reinforcement plates. The crews knew who had saved them, even if the institution could not officially acknowledge it. Fletcher would later reflect that Harker had taught him something more valuable than welding technique. He had demonstrated that institutional authority and actual effectiveness are not the same thing, that following orders and doing what is right can diverge, that courage sometimes means being willing to be officially wrong in order to be practically correct. This created a kind of epistemological crisis for soldiers raised to obey orders without question. If the orders can be wrong, if the experts can miss critical factors, if survival sometimes requires deviation from doctrine, then every soldier must become a philosopher, constantly evaluating whether compliance serves the mission or merely serves institutional comfort. Most soldiers, most people, are not equipped or willing to live in that state of perpetual evaluation. It is exhausting. It is lonely. It puts you at odds with systems designed to punish deviation. The easiest path is to trust that someone higher up has figured things out, that your job is to execute, not to question, that if something goes wrong, it is not your responsibility to fix. Harker could not take that path once he had seen the pattern. 3 tanks, same failure mode, same deadly outcome, same official response that the design was adequate. Once you see a pattern, you cannot unsee it without a kind of willful self-deception that becomes its own psychological burden. So he chose the burden of responsibility over the burden of willful ignorance. He made unauthorized modifications knowing he might be punished. He bet his career on his belief that he understood something important that the official system was missing. He was right, but he could have been wrong, and the weight of that uncertainty, that acting on incomplete information with lives at stake, stayed with him. Years after the war, Harker would tell an interviewer that the worst part was not the fear of punishment. It was the fear that he was deluding himself, that he was just another field mechanic who thought he knew better than the engineers, that his modifications might make things worse. He did not have the comfort of certainty. He had only the evidence of his eyes and the logic of his training applied to conditions the training had not covered. This is what courage actually looks like in complex systems. Not fearless action based on perfect information, but uncertain action based on imperfect information when inaction has unacceptable costs. Not knowing you are right, but being willing to be wrong in a way that attempts to reduce harm. The philosophical weight of this story extends beyond tank modifications. It is about the relationship between expertise and experience, between theory and practice, between institutional knowledge and ground truth. Every complex organization faces this tension. Experts at headquarters make decisions based on models and data and analyses that are often sophisticated and well-informed. People in the field implement those decisions and discover mismatches between the model and reality. How information about those mismatches flows back, whether it is heard and incorporated or dismissed and suppressed, determines whether the organization learns or stagnates. Organizations that punish deviation from procedure, even when deviation produces better outcomes, will drive underground the very information they need to improve. Organizations that acknowledge field innovation and incorporate it quickly will outperform those that insist all improvements must come through official channels. But acknowledging field innovation requires humility from those at the top, requires admitting that they do not have all the answers, that people without formal credentials might see things they missed. That humility is rare. It threatens hierarchy. It complicates chains of command. It suggests that authority and effectiveness might diverge, so most organizations do what the British Army did with Harker's modifications. They adopt the innovation eventually but obscure its origins. They benefit from the improvement while maintaining the narrative that proper innovation comes from proper channels. The cost of this approach is paid by the people who die in the gap between when the improvement was possible and when it was officially adopted. In Harker's case, we can count that cost. The crews of the 3 Churchills that burned before he started his modifications, and the unknown number of crews in other units who died from the same failure mode before the reinforcement became widespread. This is the mathematics of institutional inertia translated into human lives. Every week of delay, every committee that needed to review the modification, every engineer who insisted on more testing before approval, every layer of bureaucracy between field observation and design implementation cost lives that a faster response would have saved. Nobody in that chain was evil. Most were trying to be responsible, to ensure that modifications were properly vetted, to prevent untested changes that might cause different problems. But the cumulative effect of everyone being individually reasonable was an institutional response that was collectively inadequate. This is the tragedy of bureaucracy in life and death situations. The procedures that prevent chaos and ensure quality control in peacetime become obstacles to rapid adaptation in combat. The hierarchy that provides clear command structure in stable situations becomes a barrier to information flow in dynamic situations. Some organizations learn to balance these tensions, creating mechanisms for rapid field innovation while maintaining overall coordination. Others never learn, insisting that all change flow through official channels even when those channels are demonstrably too slow. The British Army in North Africa was evolving toward the former, but slowly, grudgingly, with unnecessary casualties paid as tuition for lessons that should have been cheaper. By 1944, field modifications were more readily accepted. Informal innovation was less likely to be punished. The gap between field observation and official response had narrowed. But that evolution was paid for by men like Fletcher and his crew, who survived because Harker chose deviation over compliance, and by the crews who did not survive because they were unlucky enough to be assigned to units where no one made that choice. Harker never claimed to be a hero. When asked about the modifications years later, his response was always some variation of, "I did what seemed obvious." I am not sure why it was not obvious to others. That humility obscures the courage required to trust his judgment against institutional authority, but it also reveals something important. From his perspective, it really was obvious. Once you saw the pattern of failure, once you understood the mechanics of why shells were penetrating that specific joint, once you recognized that additional metal in that location would create a deflection effect, the modification was not revolutionary. It was applying basic principles to a specific problem. The revolutionary part was acting on that understanding without permission. The revolutionary part was trusting that his field observation and technical knowledge mattered more than compliance with specifications designed by people who had not witnessed the failure mode. This is the core of the story. Not that Harker was brilliantly innovative, but that he was willing to be obviously right in an unofficial way rather than safely compliant in an officially approved way. The technical innovation was almost trivial. The psychological and professional innovation of acting without authority was profound. And this reveals something about how progress actually happens in complex organizations. It is not that brilliant individuals at the top have insights that propagate down. It is that people at the interface between theory and practice notice discrepancies, synthesize solutions, and push those solutions back up through systems designed to resist bottom-up information flow. The organizations that succeed are not those with the smartest leaders. They are those with leaders humble enough to listen to people at the interface, with systems that allow field observations to challenge headquarters assumptions, with cultures that reward effective deviation rather than merely punishing official disobedience. The British Army in World War II was, by the standards of military organizations, relatively good at this, better than the German Army, which by 1943 was strangling on its own rigidity, better than the Soviet Army, which prioritized political reliability over tactical effectiveness. But still far from optimal, still losing men to preventable problems, still structured in ways that made the Harkers of the world deviate from procedure to save lives rather than being empowered to improve procedure officially. Fletcher understood this viscerally. He survived the war, returned to Britain, became an engineer himself, and spent 30 years working in industrial design. He carried with him the lesson that official correctness and practical effectiveness are not synonyms, that the gap between them is where people die or survive, that closing that gap requires cultural shifts more than technical improvements. He made sure that every engineer he trained heard the story of Harker's patches, not as a story of one clever modification, but as a story about listening to people who see reality you do not see, about the limits of theoretical knowledge, about the cost of institutional inertia. Some of those engineers understood, others heard it as an interesting anecdote, but continued to trust that proper procedure, properly followed, would produce optimal outcomes. Fletcher could not fault them for that trust. It is psychologically easier to believe the system works than to hold yourself in constant readiness to recognize when it does not. But for those who did understand, who carried forward the lesson that reality has veto power over even the most sophisticated theories, who built careers around creating systems that genuinely listened to field feedback, Fletcher's investment paid forward. How many lives were saved by engineers who designed products that incorporated field observations from the start, who created feedback mechanisms that caught mismatches between theory and practice early, who valued effectiveness over official correctness? There is no way to count those lives, no memorial to people who did not die because someone learned a lesson from tank modifications in North Africa. But they exist, Those uncounted saved lives, the invisible dividend of wisdom hard won by people like Harker, who chose to act when inaction was safer but deadlier. The final irony is that Harker's story is mostly forgotten, while the technical specifications of Churchill armor are meticulously documented. The modification he created lives on in the design principles of modern armored vehicles. The psychological courage that enabled the modification, the willingness to trust field observation over institutional authority, the comfort with the ambiguity of being officially wrong while practically right, those lessons are harder to transmit, harder to preserve, harder to teach. You cannot write a specification for intellectual courage. You cannot create a procedure for when to violate procedure. You cannot systematize the judgment to know when your lying eyes matter more than official reassurance. These are individual choices, made in specific contexts, by people who decide that they cannot live with the consequences of inaction, even if action risks their careers. These choices are the engine of progress in complex systems, the source of adaptation that keeps organizations from ossifying into irrelevance. Harker made that choice at a welding bench in North Africa in 1943. He chose to be wrong officially rather than complicit in preventable deaths. He chose to trust synthesis of theory and observation over pure obedience to theory alone. He chose uncertainty with potential upside over certainty with known deadly downside. The shell that hit Fletcher's tank and failed to penetrate validated that choice. But the choice was made before validation was possible. Made in uncertainty, made without confidence of correctness, made because the alternative felt intolerable. This is how one engineer's stupid weld reinforcement stopped a 75mm shell and saved 5 lives and changed armor design and revealed the gap between institutional knowledge and practical wisdom. Not through brilliance, through the courage to act on obvious observations when acting violated the comfort of compliance. And the question that haunts anyone who studies this story: how many other Harkers are in organizations right now, seeing problems, knowing solutions, staying silent because deviation from procedure feels too risky? How many preventable failures persist because the person who could fix them lacks the psychological courage or institutional protection to violate procedure? How many times do we choose comfortable compliance over uncomfortable effectiveness? How many times do we trust that someone else has figured it out, that our observations are probably wrong, that the system knows better than our lying eyes? These are the questions Harker's story forces. Not comfortable questions, not questions with easy answers, but questions that might save lives if enough people are willing to sit with the discomfort of asking them. The weld held, the crew lived, and somewhere in that simple outcome is a profound truth about the difference between being right and being officially correct, about the cost of mistaking one for the other, about the mathematics of lives saved through unauthorized wisdom applied at the interface between theory and reality.